For static member variables, the thing to remember about them is the same with static member functions, that though they belong to the class, they do not belong to any particular instance of the class. So what we've got here is just a small demonstration of that scales up pretty easily, I think. Here we have the idea of a tree. So here inside of tree, you will notice that we have right here with our private member variables, a static int for object count. And every time it is that we call to the constructor, we are going to also call to get object count. So that way we create an instance of a tree object and it increments our count for us. Now, again, it's part of the class, but it doesn't belong to any particular one of the instances of the class. So here in main, when we create an oak instance, an elm instance, and a pine instance, they don't actually have that variable associated with them because it would be useless, right? It doesn't scale in their direction. We're looking to see how many trees we have, not to see how many oaks or elms or pines we have, because that would really be kind of an aggregate class, and we're going to get to those later. So here, when we call to the constructor to create an instance of our tree, we call to object count to increment that static member variable. And here we can see when it is run, we should see we have 3 trees in our program via the static member.